Hello friends, welcome to Data Science Lovers. In our last video, we learned about the diagonal function. In this video, we will learn about the transpose function. We will see the definition and syntax of transpose function. Then we will do the transpose of a 2D array, of a 1D array and transpose. Let's start. What is transpose function? The transpose function is used to convert the rows into columns and convert the columns into rows of an array, or you can say of a matrix. The simple syntax is we have to write our array dot, we have to use a letter T, means transpose, or there is an alternate way to use transpose function using numpy. We have to use numpy library dot transpose, and in the round brackets we have to pass our array variable name or array name. Okay, now first of all we will import numpy library. Import numpy as np. The library has been imported in this Jupyter notebook. First of all, we will see transpose of a 2D array. As you all know how to create an array using numpy, the syntax will be np dot array round brackets and two square brackets because we have to create a 2D array. Now we have to pass the elements of this array 1, 2, 3, and for second row I will write 4, 5, 6. Okay. We will save this in a variable a for our reference. When I print this 2D array, you can see it will look like this. It has 2 rows and 3 columns. Okay. Now if we do the transpose of this array, then as per our syntax, our array name dot t, when I run this, you can see all the rows are now converted into columns and all the columns are converted into rows. 1, 4 was our first column. Now this becomes our first row, 1, 4. 1, 2, 3 was our first row, and after transpose 1, 2, 3 becomes our first column. So that's how simply we can use transpose function on a 2D array. Now if we want to check the shape of our original array a dot shape, then it is showing 2 rows 3 columns. But if we check the shape after the transpose, then it will show 3 rows and 2 columns. Okay. Now alternative command to transpose is using numpy library np dot transpose function, and here we have to pass our array. Our array is stored in the variable a, so I can simply pass a here. When I run this, you can see this is the output of array a after transpose. This is similar to the. Now we will use the transpose function on a 1D array. First of all, we will create a 1D array, and the code will be simple. np our numpy library dot array function. Inside this array function, we have to pass the elements for our 1D array. Suppose I pass 11, 12, 13, 14, 15, 16. I am passing 6 elements here. We will save this in a variable b for our reference. So this is our 1D array with 6 elements. Now if I do transpose of this 1D array b dot t, then there is no change after the transpose. Means for 1D array there is no change using the transpose function. We can also check the shape of our original 1D array b. It is showing 6 elements, and after transpose also it will show 6 elements. Okay, so this is the property of transpose function on 1D array. There will be no change. Now we will use transpose on a 3D array. First of all, we will create a 3D array using array function from numpy library. Here I have to pass 3 square brackets because I have to create 3D array. I will pass the elements for our array 1, 2, 3. Next I can pass 4, 5, 6 and 7, 8, 9. We will save this in a variable c. When I print c, you can see this 3D array is containing of one matrix, and in this matrix there are 3 rows and 3 columns. When we perform transpose function on this array c, then it will look like this. It will become clear to you when we will check the shape of our original array c dot shape. It is showing 1, 3, 3, and when we check the shape, After transpose, it is showing 3 comma 3 comma 1. Okay. Now what is happening here? Earlier our C array was having one matrix, this one, and 3 rows and 3 columns. Okay. When we do the transpose of this 3D array, then after transpose, the shape is changed to 3 matrix. You can see this is our first matrix, this is our second matrix, and this is our third matrix. And each matrix having 3 rows. In first row we have only one element 1, in second row we have 4, and in third row also we have only one element, and same for the other two matrix, only one element in each row. And last is for columns. In each matrix there is only one column. This column containing 147, this is containing 258, and this is containing 369. So that's how we can perform transpose of a 3D array. So friends, this is simple. In our next video, we will talk about the unary operators from numpy library. Okay.